This is our first video in a series on chemical reactions. Topics for the upcoming videos will include balancing chemical equations. Being able to balance a chemical equation is very important because once we have a balanced equation, then we can use a reaction like a recipe where you plan how much product do you want to make. This branch of chemistry that deals with quantities in a reaction is called stoichiometry. There will also be videos about common reaction types and predicting the products of a reaction. Now this particular video is going to focus on trying to give a background for working with chemical reactions and how to interpret the information that's represented in a chemical equation. Let's work our way through some basic terminology. The reactant is a substance that acts as a starting material for a reaction, and so it can be thought of as an ingredient for the reaction. These appear on the left side of the chemical equation, so NH3, ammonia, and O2, oxygen, are the reactants. The products are the substances that are produced in a reaction. They appear on the right side of the equation, and so nitrogen monoxide and water are the two products. Coefficient, those would be the whole numbers that appear in the front of a formula, and so that would be the 4, the 5, the 4, and the 6. This is not to be confused with the subscript, such as in NH3 there is a 3 there. The subscript indicates how many atoms are bonded in the formula. Finally, the law of conservation of matter just means that matter cannot be created or destroyed. And so what we have in a chemical reaction is that the atoms are rearranged, bonds are broken and bonds are formed, but no atoms are created or destroyed. So the law of conservation of matter then becomes the basis for how we're going to balance an equation. If we take a look at the reaction up above, we have 4 nitrogens that are on the left and 4 nitrogens are on the right, and so those are balanced. They obey the law of conservation of matter. We'll look at one other one. We have 12 hydrogens because there's 4 NH3, so it's 4 times 3 is 12. And on the right hand side we have 12 hydrogens as well. And so you can see that everything is balanced. Let's talk about some of the symbols that you might see in a chemical equation. We have the reaction arrow, which usually is just red as reacts to form or yields. Sometimes you'll see things like AQ or S, and those are the states of matter, so you can see that they have solid, liquid, gas, and aqueous as possibilities. In the reaction that we have above, it's kind of interesting. We started off with 2 solutions. You can see there that both of the reactants are aqueous, and then we have a product that's formed that is not soluble. It'll be a solid that'll sink to the bottom of the beaker. This type of reaction is called a precipitation reaction. And so a precipitate is a solid product that forms out of an aqueous solution. The reaction at the top features a hydrocarbon. That's an organic compound that contains only carbon and hydrogen. So that's the C3H8 here right at the beginning, which is a substance called propane. We also have a diatomic element, which is oxygen. And a diatomic element is an element that when it's not in a compound will pair up with itself. So these are pretty reactive elements. They are all nonmetals that are like this. And this is something that we're going to have to be able to memorize. And so here's a couple ways that we can go through and try to memorize which ones are the diatomic elements. There happen to be 7 of them. Part what you could do is look at how they're located on the periodic table. The 7 diatomic elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And so that sort of forms a 7 on the periodic table that points at the 7th one. Phosphorus and sulfur are also a little bit unusual. They are not diatomic elements, but phosphorus and sulfur like to combine with themselves when they are not in a compound, such that phosphorus likes to cluster together to form P4, and sulfur likes to cluster together to form S8. So getting back to the diatomics, there are two other ways that we can go about trying to memorize these. It turns out that every single one of those has an ending of either GEN or INE. The ones that end in GEN are hydrogen, nitrogen, oxygen, and the ones that end in INE are the ones that are the halogens. It's fluorine, chlorine, bromine, and iodine. And so the U is just a little connector letter to make a word, and so genuine gives you a way to kind of keep track of which ones are the diatomic elements. Now there's one at the bottom here that just has the letters together. If we just say what it looks like as a word, Brinkelhoff, that can help just kind of remind you of what they are. So you can see that the 7 diatomics are just listed in such a way that they kind of spell out a word.